Um, Hopefully, chapter 1 and 2 were pretty good, not too bad. Um, and now we're on to chapter 3. So, chapter 3 is pretty long, and there's a lot of parts to it, a lot of moving parts, because there's a lot of moving parts to statistics. So, we're going to take them in little chunks so that we're not having one long video for all of it. So I'm going to do a portion of it on this video, and then we will get to the other portions later on. Now, this is just kind of an overview. I wanted to have you have a little knowledge of statistics and how it relates to business. Um, if you go on to further classes, you'll see more of this, but I wanted to kind of just give you a little overview and some of the like I said, the basics of it. And then I also have a project for you at the end so that you can apply it, because I want you not to only know in this part, we're going to go through all the formulas and all that, but in the project, you're going to more apply it to a situation. And in that also, not just the formulas, but you could probably also use a calculator or something like that. Although you could probably use it here too. So, but we have to know how to do them. I will warn you that some of these formulas look pretty daunting, but if you just work on it, you can get it. Okay, it just takes time. I know it takes time. I know all of this math does take time, and a lot of you might not have taken a math class in a long time or never seen math like this before. And so it concerns you and it scares you. But I'm here to help you to work through that. And hopefully, through these videos, I can do that. And also, as I tell you in every video, please reach out to me if you need some help on any of this, because practice makes us better. I don't know, it might not make us perfect, but it could. But it does definitely make us better. So here we go. Um, Chapter 3, Business Statistics. And hopefully, too, I got some feedback that the screen, some of the words were coming off the screen and stuff. So I'm going to try when I edit it to fix that. I'm a work in progress, just to let you know. So anyway, we're going to start with 3.1. We're probably going to do 3.1, 2, and 3 maybe in this video. It just depends on how long it gets and if I feel like that we need to take a break. So anyway, so when we first start off talking about statistics, you will see that in many of your math classes, business classes. We also look at it when we talk about graphs. So, we've talked about graphs a lot. But so here, for example, we're seeing that there are some grades assigned to some students in a calculus class. So you see the grades, F, B, B, yeah, all of those. Okay, so we call that data. Okay, data is helping us making sense. Grouping is helping us making sense of that data. So we have the data and then we group it in different ways to help us make sense. We want to know, okay, well, how many A's were there? How many F's were there? And what does that mean? Why would somebody care? Maybe because they want to evaluate whether their processes, the teacher might evaluate whether their processes are working, what they need to do something different for a test, or whether they need to focus on one person. We organize the data into tables and charts to help us understand it. You've seen a lot of the different charts. You've seen misleading ones where they don't start at 0, or they have different, but so you'll see a little bit about creating your own graphs with this too, and it is a little bit of figuring it out and making groupings that makes sense. And so you'll see that too. So it's not always just the hard and fast. So we're going to keep looking at that. The frequency distribution is something else we're going to look at. It's a table that shows how many times each different data value occurs. Okay, so that means how many, like for example, when we look at this list up here, excuse me, how frequent did A's occur? How frequent did F's occur? Okay, and then from that, we can put it together and look at how they're distributed. We can also look at frequencies for categories of data. So grades, like letter grades or colors. But we also use it for numerical data, of course, for uh, the prices of items. So we're going to look at, here we go, here's our list of grades. We are going to look at the frequency distribution and a relative frequency distribution of these grades. So again, like I've said in the past, there's more than one way to find the answers. My main hope for you is that you find the correct answer and that you use the method that works best for you. So in this, we could scan the list and we could count the number of A's, number of B's, number of C's, and then we could keep tallies of each of those. Okay, so you can, it just depends on how big the list is. Now, sometimes you're going to have a lot of data, a lot. And usually you would evaluate that in a spreadsheet formula, spreadsheet software like Excel, and it can do a lot of calculations for you. So that helps out a whole lot instead of having to count all of these. And so that's great for us then when we have those, so we don't have to count them all one at a time. Can you imagine what it was like before we had all of that and we had to actually count? And the ones that those mathematicians that created all this, they had to spend all of their time. So anyway, um, so here's the grade distribution, and you can see that. So grade A, there were 3. So if we went back up there in this little thing and we counted 1, 2, 3, yeah, 3 A's. Okay, so that's how we're counting them. You probably want to double check, of course, on your count, to count and make sure that, you got the right numbers. So hopefully there's 19. So you could have counted all of them and said, oh, yeah, there's 19. So we can look at this and, we're starting to get an idea of what we're looking at. We're starting to make sense, right? It's starting to look a little bit better because you can just look at this information and say, C's occurred the most because there was 8 C's, and D's occurred the least. And then we can think, okay, well, that's good to know. But what else can we know, right? What else are we going to figure out about this? Okay, so let's go on and we're going to figure out some more ways that we can figure it out. Okay, so here we get into the next part, which is our relative frequency. Okay, so we know that there are 19 grades, right? There are 19 grades, and we added that up and everything. Okay, so to get the relative frequency, we're going to divide the frequency by the total, which the total is 19, right? So we're going to take each one of these and we're going to say 3 divided by 19. And that's going to give you the relative frequency. So how frequent that is occurring. A way to check yourself, of course, your rounding is going to make a difference. Remember to keep it to as many decimal places as possible. We recommend 4 here at this point. Your frequencies should add up to 1. If they don't, you might have a slight rounding issue going on, but as close to 1 as possible. That's what we're looking for, and that's what the frequency should add up to. So there we have it if we just had the list of 19 grades. So what do we do if we have a lot more, or we want to group them? Excuse me, because we kind of want to make sense of them that way, because we might go, well, we have a lot. The ABC thing, that worked, but I've got a lot more here, and if I try to draw a picture of that, that might not show what I really want it to see, or what I really want people to see from it, right? Because that's part of the point. Um, Especially, like, if you're working on a project for a supervisor and they're asking you to put together a PowerPoint presentation and they wanna see graphs. They don't wanna see all the numbers and all that. They don't wanna see how you got there. They wanna see the nice, pretty picture that you created from all of that data that you crunched and, have all those gnarly spreadsheets for, right? Um, so this is a way that you can help to group it to make it make a little bit more sense. So this example, we're going to talk about calorie counts. Oh, a horrible subject, especially when it has to do with um, espresso oop, espresso drinks from Starbucks. So I know you don't want to see this. I know we all know that these drinks have a lot of calories in them, but here we go. So looking up the calorie counts of the different grande size drinks at Starbucks had this range of calorie counts. Okay. This is from, it's 190 on this end to 400 on this end. Okay. So how can we make sense of that? So that's what we want to do. So we're going to look at the frequency distribution, the relative frequency distribution. We're going to group the data, and we're going to see if we can help this data make sense. Okay. So we look at the data. I think the best thing to do, and it's going to come in handy later as well as we go through this, is to put the numbers in numerical order. Okay, so that will help you to determine the smallest number and the largest number. So we see that when we do that, we see that the numbers range from 110 is the lowest number of calories, and that probably is not the best tasting of the drinks. Anyway, and the highest is 440. That probably tastes really good. That's probably a mocha double chocolate chip. I don't know. Anyway, okay. So what we're going to do is we're going to try to group the data. So in this, we want it to make sense what the groupings are. We kind of want them to be as equal as possible. And that typically is the best way to show it. I've seen examples where sometimes they're not equal, and I really think that makes stuff misleading. But, we'll look at that and see what makes sense as we go along. So, we're looking at the range of values. So the range, it ranges from 40 to 110. So in this example, if we subtract 440 from, or 110 from 440, we get 330. We're looking at, we're talking about, we just think 4. Okay, that makes good sense. We're going to divide it between 4 because we want to group the data into 4 equally spaced classes. So we're covering the range of all of the values. So remember it started at 110? So our category actually starts at 106. We don't have anything specifically at 106, but we're looking at that grouping that contains that group of numbers. You want to at least have the numbers that are included in the data set. So you want to at least have it start at 110, and you at least need to have it run through 440 so that you're making sure that you're including everyone. And so when we do that, we count them up again. We have to do that counting, unless of course we're using a spreadsheet software or other kind of um, software like that to help us to do this. And you will see that, um, when you have to do big projects and stuff for your supervisors, you're going to more see that. It's not going to be a lot of this, doing it by hand, but it's important for you to know how to do it by hand. And so that's why we talk about it. And it's good to see the science behind it, I guess you could say. So we got this little table which contains the calories in the groupings, okay? And you can see the differences there. And you can see that most of them are on the lower end of the calorie range. And there's only less than half of them are at the top end. So you can see that there. Um, you can also, again, um, get the relative frequencies when you have a group. So you're doing the relative frequency of not just each piece of data, but the the grouping. So we know that there was 8 in the 106 to 190 range. So if we divide that by the 22, which was the total pieces of data, so the 22 drinks themselves, then the relative frequency of the drinks being between 106 and 190 calories is 0.3636. And then again, if you added all this up, again, we are looking at, checking your data, checking your work. It would add up to, about 1, because remember with the rounding, then it could be different. And we also know that this should add up to 22, and we know that it does. So, like I said, we have several choices in grouping data. You need to look at the classes. We could space them equally. We could have started them at 100 and ended at 500. It just really depends on, I like to think that, what is the end picture going to look like? I mean, you want it to be accurate, of course, yes, but also you're trying to paint a picture too, because that's your end goal. You're painting a picture for your supervisor or whoever to show them your findings or your results. So you want it to make sense. So that's what we're trying to do. We're trying to make it make sense. We're trying to not mislead anybody. So we want to make sure that we are looking at, some really accurate as much as possible. One example, and I kind of talked about that this is possible, that if they weren't of equal width, is when we're looking at household income. That's one example. I can also think of another, like salaries of NFL football players or NBA, because there's such a wide range. Because when you get, and you can see this in this household income in 2020, and we've got it broken down under 15,000, then 15,000 to 24.99. So that's about 10,000 right there. But then it gets higher as you go along, because the next one is about 25 between that. The one thing that I will mention on this is that you need to be very careful about your groupings because um, they need to make sense as far as you don't want. So, for example, you see on this the second row, it says 15,000 to 24,999. The next row starts at 25,000. So you're not overlapping. Your second column doesn't end in 25,000 and the third one start at 25,000 because then where would you put it? Because that number could possibly be in either one. So definitely um, making a clear um, difference between the two. So, and the reason why the second one can say 15,000 is because the first one says under 15,000. You could have said 0 to 14,999 if you wanted to. Okay, so that would have made sense too. So, so this is the way we wanted to, for example, of putting this together. Um, So we want to another thing that, in this, if you wanted to even think about it, the difference that that much money makes to those different people. And that's what the example gives on that is how much impact that just that little bit of money could have on different groups of people. I mean, you could also, if you were looking at it, divide it into um, the tax percentages and things like that, and have each one grouped like that. Look at commonalities in the different organizations and how they group the data because it's kind of nice to have it, basically say, okay, this is what they said and this is what we're saying on this. And the data matches because a lot of times it doesn't. So you think you're looking at the same thing, but you're really not. Um, you're not measuring the same thing and you're looking at apples to oranges instead of apples to apples. So you really want to make sure that you're really looking at, is this really saying the same thing? Is this really the same data or is it something different? So that's really important for you to remember as well on that. Okay, so hold on just a second. Okay, we've talked a lot about graphs, not just a little bit. But we can use bar graphs to make pictures of our the data, and we can show it. And like I said, so that we can show it to our supervisors, so that they're not seeing. They don't really want to see this. They don't really want to see these tables with this grade distribution with the relative frequencies. No, I don't know. Some might be data geeks, and I love looking at data. So, I mean, that's cool for me, but most people don't. Um, so there you go. So here's your original grade distribution, and that's from the earlier one. Remember, we had 19, and then we had these relative frequencies, which we figured out, which we did what? 3 divided by 19, right? Because 19 was the total number of um, pieces in that data set that we had. And so we did the 3 divided by 19 and got the 0.1579 for that one. And we did all down the road. So we are going to make this into a graph now. So how do we do that? Okay, so we're looking at it and we are again we're kind of just trying to see what it's going to look like, what we need to include. We saw that the largest frequency was 8, so on this scale they decided that the top number was going to be 8, and you do see it goes from 0, so that's a good thing. So we know that we're not misleading in that way. um, so but we could have gone to 10, we could have there's a lot of things that we could have done, but in this situation, we went to 8 for the frequency, and, then we put the letters, the the, um, the grades on the bottom, and then you see this pretty little graph that comes up from that. And you can see here again, like you saw in the table, that 8 was the highest in C, and you can easily see that. Now, I know that it's kind of hard sometimes to judge that, and I know a lot in your homework that it comes out and it's like you think it says one thing, and excuse me, it doesn't come out that way correctly. Um, and that's one reason, though, I look back at your homework too and say, "Well, could it be that? It's kinda close." So, yeah, that makes sense. Okay, so that's part of it. But here's the bar graphs of grades by the frequency. Um, so then we have the relative frequencies. So first we just had how many of each, right? And then we look at the relative frequencies, and it went up to 0.4211. So we decided in this example to go to point 0.5. Like I said, the last one we could have gone to 9 or 10 or whatever, to make it look decent. But so then you see the relative frequency. It's interesting if you look at this that the relative frequency kind of looks like the other bar graph too, doesn't it? Hmm. I wonder if there's a commonality or reason for that. We'll get to that. Okay. Um, so we can do the same thing with the group data. Again, we're talking about our calorie-ridden, yummy espresso drinks. And we have those in our 4 categories that we made. And we have our relative frequencies. Remember, there's 22. So we said 8 divided by 22 to get our relative frequency. And we did that for all of those. And what else? The relative frequency is supposed to add up to 1, right? Okay. Just testing you a little bit as we go along to make sure you're getting this. Um, so now we're going to do a bar graph of those two as well. So we've got our frequencies, and then we've got our calorie counts, and we've got our bar graph that's depicting those. Then we're going to do our relative frequency the same way. And again, they look pretty much the same, don't they? They look pretty much the same. Now, we don't have to group the data. We could have, in this situation, we could have done every single one of the different drinks and every single one of the different calories, but it would be a lot. When you have a smaller data set like you did the A's through the F's, it was a lot easier to show it as the number of A's, the number of B's, C's, D's, F's. In this situation, um, it just makes more sense to group the data together so that you get you get a better picture of um, what is actually going on. The next type of graph, it's kind of like a bar graph. It's a special bar graph. It's called a histogram. So in a histogram, we are using the frequency and relative frequency. Um, but if we also have, and like we talked about with the grouping, if we have a large number of values, then this tends to help out a bit in your depiction and your data. So for this example, this is the first example on this. And so we're looking at heights. of female students in a college class. So there's all your different heights. So we want to construct a histogram for the values. First, we want to group the data into classes of widths 2, starting at 59.5. And then we want to do that in classes of 4, starting at 59.5. Why is that? We want to see what it looks like, whether it makes sense to do it in um, a width of 2 or a width of 4. So if we look at this, and even from just looking at this table, it, to me, I can see, and if you just glance at it for a second, there is one grouping that has nothing in it. So what would that do? I mean, yeah, that would give an accurate depiction, of course, but do we want there to be that 0 in there? It just depends. We're also seeing a lot in the 63.5 to 65.5 range, 10. Does that tell us a picture? Does it not? I don't know. We'll see. Again, we're getting the frequency and the relative frequency. How many were there? There was 12, 22, 31, I think. Yeah, 31. So 5 divided by 31 gives you that 0.613 on down the line. And that's where we get our relative frequencies. So when we talk about use a histogram, instead of the bars being separated, they are done together. And the other thing that you do see on this is that instead of, like we talked about for the bar graph, remember we said the numbers couldn't be the same. In this one, it goes to 61.5 and then it starts again at 61.5. Basically, that's meaning 615 and above, because we're looking at inches and we know that, they're not going to be exact. So when we do that, we come up with this little bar graph. And you see where there was the 0. So we have the gap there, and it looks pretty equally distributed, which we'll talk about. But there is that 0. If we did the width by 4, which was that next section, again, we still have the same number. 31. I don't know what I counted before, but and we did that division and got the relative frequency. And so if you look at that one, that looks a bit different. It looks a lot different. So we just have to think about what makes most sense. But we would like our data to be in or look like a bell curve, which we're going to get into and talk about. And so we want to try to look like a normal distribution or a bell curve. And so that's why we try to look at the data to see if we can do that. More on that topic later. Um, we'll also talk about pie charts, and we've seen those before too. Remember, I talked about the whole in chapter 2, the part of the whole. When we look at pie charts, we can figure out the relative frequency by multiplying, or figure out the angle by multiplying the relative frequency by 360 degrees, which is the full circle of the pie chart, because circles equal 360. And so here we have the protractor. I don't know if you remember using those little plastic things in elementary school and middle school. They broke very easily, but anyway. So we could use that, or we can, in our pie chart, we are going to look again at the grade distribution that we did before in the bar graphs. So we have the same one before, same thing again. 19 grades, right? Get the relative frequency, 3 divided by 19, 0.1579. We want to again check it, right? To add up our relative frequencies and make sure they add up to 1. I think y'all got that. So we're going to draw a pie chart that represents that distribution. So we are going to look at it by percentages. So we are going to multiply that relative frequency we got. Remember, we got the relative frequency by saying 3 divided by 22 to get 0.1579. Okay, but then we need to figure out the angle measure, so the degrees. So if we did 0.1579 times 360, we're going to get approximately 56.8 for that, that measurement. And you can see as we go down, it's the same thing. 0.2632 times 360, you get about 94.8. Again, these are going to be approximate. We want to do the best we can. Also, when you're making a graph, it's up to you, but typically it starts off at the 12 o'clock position, and we're marking the angles in succession, so A, B, C, D, and F. So we can complete our pie chart, and we can see that the A's were 15.79% and on around. And, excuse me, we've even labeled it, which is a great thing to do because it helps to know, how many students were there. I mean, 42% of what? Was it 100 students? If you don't mark that on there, then, it's harder to be able to tell what exactly it would be. So, can we use a pie chart for grouped data? Yes, we can. We have the different regions of the country and the frequency of persons below the poverty level. So we're going to compute the relative frequency distribution, and then we're going to draw our pie chart. So there we go. We got our numbers. We've done our frequency in thousands, and we divide that by the total number of people below the poverty line in the 4 areas, the 4 regions of the United States. When we divide that, we get, for example, when you divide the first one, we get 0.1491. So, for example, let me add that up and then I will tell you. So 5555 plus 6812 plus 16619 plus 8261 is equal to 37,247. And you should probably write that down somewhere because you're going to use it a couple of times. So it's best to make sure you write it down correctly. And so then I'm going to go 55,000 divided by 37247. And hopefully, I did 0.149. So there would be my relative frequency. And then the next step, we measure by, what's the size? 360, right? Times 360. Yay. 53.69. And hopefully you get it. If not, maybe your numbers are wrong. That happens sometimes. Just go back in and do it and check your work. Make sure you get it right every time. Sometimes it's hard, especially if you have a big, huge list of numbers, they don't always add up right. And if you have the answer, what I think is so great is, especially on these when you have your homework and, you might have gotten one wrong and it gives you the answer. And you go back into the problem and reverse it to see, oh, well, how did I get that wrong? So you can plug them in, especially if there's a formula, plug them into the different spots. I'm thinking back to the PBR um, in chapter two. You can plug it into the different spots and figure out, okay, well, this was supposed to be the base, so why didn't I get the correct one? So just kind of a little help on that. So then we have our pie chart with our frequencies, and we have our total. Um, so that makes a nice little pie chart for its two. Um, Again, we talked about with the relative frequencies how sometimes they won't add up to one totally because of um, um, our rounding. And these might not add up to exactly 360 due to rounding area errors, but we want to do this the best that we can, and especially if we're going to publish it or send it to our supervisor, is probably a good idea if it did add up to 360 and add up to 1 and all of that, because, they could catch that and they could say, "So why didn't this add up? Is it not correct?" And if they see that wrong, are they gonna just throw out your data because they see one thing wrong? So, just something to keep in mind. Um, we can also use pie charts, when we look at budgets, um, and we would look at the frequency as a keep forgetting whether I'm supposed to say yes or no on that. Um, anyway, I think that for now we have done really well on 3.1. And I think it's time to take a short break and figure that all out, digest it all. And then I'll come back later and we will work on section 3.2, which will be central values. Again, please contact me if you need any help at all, if you need any further explanation for any of this, or yeah, you need help. So thanks a lot. Looking forward to seeing you again soon. Bye for now.